Welcome to GKE Releases Management and Strategy session. My name is Kobi Magnezi. I'm a product manager for GKE, Google Kubernetes Engine. And I have the pleasure to have here with me Josh Hoak, Zach Loafman, and Daniel Loreto. We are going to speak about non-trivial challenges that we have with managing GKE at scale and managing different releases of Kubernetes at scale in the GKE fleet. What can you expect from this session today? One, we are going to start with just a quick overview of Google Kubernetes Engine, the way we manage the different building blocks of Kubernetes in the fleet. Two, we are going to speak about some challenges. Those challenges present some limitation, but also entice us to think about different ways we can simplify and streamline the release process for you. Three, we are going to speak about Kubernetes at scale. How do we take an open source Kubernetes version and funnel it through the power engine of GKE and make it available for you? Four, we are going to speak about tools and capabilities that we provide you so you can manage your risk and you can manage your clusters. And then five, lastly, we are going to share with you some of the upcoming features that will give you more flexibility and control over the GKE releases. In this Google Next event, we also introduce a new capability, so the Dory Q&A. You probably have seen it in different sessions. Feel free to open your app, the Google Next app. You can find the link to the Dory Q&A under our session. You can submit questions now or after the session. We're also going to have two microphones here, and you can ask your question using one of these microphones. We have a moderator here that will help get the question that you post online. And so after this session, we'll go through some of these questions. So let's start with a quick introduction into GKE. Josh.
Cool. Thanks, Kobi. So I work on fleet management and a lot on the releases. So I'm going to first start with what is GKE. I know you've heard a lot about Kubernetes, but just so everyone's on the same page, I'm going to talk a little bit about Kubernetes in Google Kubernetes Engine. Right. So I said two things. Google Kubernetes Engine is a Google Cloud service. It's that box within a box. And then you have Kubernetes, which is a container management system. You might have heard it orchestrates containers. And typically when I think container, I'm thinking like Docker containers, and I'm thinking things like rollback and deployment and scheduling and stuff like that. So in Google Kubernetes service is a Google Cloud service, just like and many of our Google Cloud services, and you can interact with it via the API, CLI, or UI. So, but Kubernetes is like a heterogeneous thing. And when I think about Kubernetes, it has two big parts. It has the Kubernetes master, and it has the Kubernetes nodes. And the Kubernetes nodes are where users run workloads. And then the Kubernetes master is where we run all the little tiny pieces that make up the Kubernetes control plane, if you will, that manage Kubernetes. So we, Google, are in charge of managing your master, and you are in charge of managing your nodes. And there's many different things you can do for your nodes. You can opt into node auto upgrade, but ultimately it's your responsibility. So after you've created a cluster, now you have something that you can interact with, and you can interact with kubectl, and you can create pods and deployments and so on, or you can use the API. So now I'm going to pass it to Zach, and Zach's going to talk a little bit more about the internals of Kubernetes.
Hey, thanks, Josh. So as Josh alluded to, I'm going to give you a little look under the hood for Kubernetes. This is super basic, but the basic Kubernetes architecture is that you have these containers. As Josh said, these are Docker containers. You have pods, which are collections of these containers, nodes that those pods are running on that then talk to a master, which controls the cluster, and it uses etcd as its backing store. But that simplistic view hides a fair amount of complexity of things that we manage for you under the hood. We run almost 50 different Docker images on the master. This slide is just a sample. They include obvious things like the API server you're familiar with, you might be familiar with a Kube API server here. etcd. We run all of those on top of kubelet, but they also include other things on the master, like support pods for logging and monitoring and metrics, networking, scheduling, etc. We also manage the software that runs on the nodes, including the OS image and kubelet. And as part of the master version, which we'll get into in just a little bit, we manage a series of add-ons. This includes support for logging and monitoring of your pods, and also things like Istio and Knative as well. And on the nodes is obviously your application as well, running on top of our OS image and kubelet. And now I'm going to pass it over to Kobi to talk about some of our challenges here.
Thanks. So Kubernetes is indeed a very powerful framework and platform. It's basically a microservices framework built on top of microservices. Pretty awesome. But with all this large set of building blocks, we face the challenges of coordinating and qualifying different releases. Going through these specific challenges, I think it will help us understand kind of the reasons and the drivers we have to simplify the process for you guys. So Kubernetes is, or Kubernetes communities, is a super engaged community. It drives lots of code changes. This in turn translates to quarterly releases of the open source Kubernetes version. On top of those quarterly released version, there are patch versions, which include some bug fixes. And there is also GKE releases, or GKE patch releases, which includes basically the magic glue that we have to integrate Kubernetes with the GCP infrastructure, which then in turn allows you to use GCP capabilities through Kubernetes. For example, you can use GCP preemptible VM as preemptible VM under Kubernetes cluster. In this specific example, you can see the amount of version that we basically support in the fleet right now. So if you open up a gcloud command line and query basically the list of versions that we support, and you can actually ask for a specific region, you will see what version we support for the nodes and what version we support for the master in every specific geographic allocation. So that's definitely one challenge, having this amount of versions to support. The other thing that we need to take care of is the version skew policy. So the open source Kubernetes policy supports 2 minor versions. So let's take 1.14, that's the latest version. When 1.14 becomes available in the market, the official support would be for 1.13 and 1.12. However, it doesn't really end there. As you probably remember from the explanation we just got from Josh and Zach, there are 2 main components for every Kubernetes cluster. There is the master and there is the node. And each one of them can have different versions. Obviously, we encourage you and we want our customers to have the same version in both the master and the nodes. But the supported version skew allow nodes to be up to 2 minor versions older than the master. And the next challenge, the final one, probably the more crucial one, are security fixes. And obviously, the sense of urgency to roll out these security features, security patches, is higher, especially when there are some critical issues like the one we just experienced last December. So you don't need to lean forward to this. I know it's kind of an eye chart. But in this case, there was a security issue with the Kubernetes API. We patched it, and we quickly roll it out to the entire cluster. So no action was actually required from our customers. If you use GKE, you benefit from the rollout of these patches. In these cases, in the security issue cases, GKE team will do their best to identify, resolve, and patch the entire fleet and your clusters as well to keep your workload safe and secure. For GKE, as a managed Kubernetes service, we strive to remove that level of complexity that I just described. And how we deal with all these challenges, Josh is going to give us some details.
Cool. So really, when I think about release of Kubernetes in GKE, I'm really talking about how do we get the open source software into Google Kubernetes Engine. And I see it as having like 5 main phases. So the first phase is is the open source release happens. And I'm going to elide a lot of stuff here, but the open source release is quite complicated. So, I mean, there's a whole process of release qualification, and you have to write release notes, and all the, I don't know, Kubernetes has these special interest groups that are a sort of federated way that features are created, and all these people have to get together, right? So, but from my perspective, working on GKE, I kind of wait for that process to finish, and then boom, they come out with a new version. Then we import that version into internally, and we start applying our patches on top of that. After that, then we qualify the version, and this is like can be quite a long period of time, sometimes weeks or months, depending on what the version is. And then we, at some point, we're like, okay, it is time to release a new version. Let's cut a release candidate. So we cut a release candidate, and then that period is about roughly 1 to 2 weeks, and then we roll it out to production. Of course, assuming everything works perfectly. And then once it rolls out to production, we actually have a 4-day rollout period. So if we roll it out to a couple locations first and a couple locations next, and then, well, more than a couple, and then we gradually do all the locations. And we try to put this all in our release notes. Now, of course, these days might not happen like sequentially. We might pause it if we find an outage and then fix the outage before we proceed on. But this is sort of the sequential order. So what are we releasing? So when you see like, oh, we're releasing a new version of Kubernetes, this is kind of what Kobi was getting to. That we have these 4 different version numbers. So we got the minor version, we have the Kubernetes patch, so those both come from upstream. And then we have the GKE specific patch, which is what we're adding on top. And what corresponds to that? This is kind of our identifier for the software. This is the collection of software that we release. The OS image, Kube API server, kubelet logging, whatever. So it's a very important number. And remember, we have 2 versions. We have the master version and we have the node version, and those are separate. Again, because of this shared responsibility where we own the master and we are sort of in charge of that. I mean, you can upgrade your master if you want on your own, but we will do it eventually for everyone if you wait. And then there's the nodes, which you can opt into node auto upgrades, but ultimately it's your responsibility. And we have to sort of manage these things. So, and that gets into upgrades, like how do we upgrade the fleet for both the masters and the nodes, and Zach's going to talk a little bit about that.
Cool, thanks. Most of the users of GKE EU experience our release process during upgrades, whether it's a master upgrade, which we initiate, or whether it's a node upgrade, which you have the option of initiating yourself or managing through us. So first, let's talk about the masters. Master upgrades are managed and, like I mentioned, typically initiated as part of the GKE release process. Workloads running on user nodes just stay running during the master upgrade process. When we upgrade the control plane, we also upgrade all of our managed add-ons as well. So as you can see in this picture, the master is upgraded along with the versions for Istio, Knative, and as I mentioned before, all those logging and monitoring and metrics support add-ons, all while your user application is running. So how do we do it? We upgrade zonal masters in place by creating a new master with new software. Then we shift the disk and network over, and we kill the old master. We do this pattern for zonal masters. For regional masters, where there are 3 HA masters running, we do a very similar pattern where we spin up 1 more master, and then we kind of roll through doing a rolling update on the masters. So node upgrades. Node upgrades are a very similar process, but they're more visible to you. In GKE today, you can actually choose who manages the node upgrade, and I'll get more into that in a little bit. But if you have node auto upgrade turned on, we will initiate the node upgrades for you, and if not, you'll initiate them yourself. So how does a node upgrade work? Well, it's actually a very similar rolling update process. What we do is we create a new node at the new version. We cordon off and drain the old node. the workload shifts scheduling to the new node, and then we kill off the old node. This actually isn't exactly right. What I just showed you was a feature we have coming up soon called surge upgrades, where we will actually give you the capacity for one more node as you're doing the upgrade. Currently, the way the picture works is we cordon and drain an existing node and then add that back in after we've deleted it. So over to Josh to talk about the version lifecycle.
Cool. So like you might be wondering like why do we have so many versions? And part of that is just the natural life cycle of the versions and really this how it relates to this upgrade process. So I'm going to first talk about minor versions of Kubernetes, and even though it's in many ways the minor version is kind of a major version, but it's sort of the feature version of Kubernetes because that's what most people care about. All right. So what does it look like in my head, and how do we sequence this? Well, normally what happens is when we release a new minor version, there's a period of time when it's a new version. And what that means is it's available for you to choose to use, but it's not default. And so you can use this to use new features for GPUs or TPUs or whatever. At some point, after about maybe a quarter, we decide to make that the default. We're just like, okay, we're pretty sure that this is a solid enough version for the entire fleet of GKE clusters. And then when we shift over the default to the next version, now we start to phase out the old minor version of Kubernetes. So now that gets into upgrades. When do we do upgrades? We do this in the phase out period. So during that third period of time is when we start to do the master upgrades, and we upgrade everything that was the default but is no longer the default to the new default. Sometime after that, we upgrade the nodes to the new node version for those customers that have the node auto upgrade enabled. And patches work very, very similarly, except that the phase is much, much shorter. So typically for a patch, we're not talking about the order of weeks rather than quarters. So we release a new patch, and then we migrate people over. And it sort of happens in rapid succession because patches are bug fixes and less invasive. And that's about it for the version lifecycle. So now I'm going to pass it over to Kobi to talk about how you can manage your risk.
Thanks. So now that you have visibility into kind of the behind-the-scene process of how we release Kubernetes and the strategy we have, I think it's important to know what controls you have today, control that enable you to manage risk, and also control the disruption. I would say the first thing that might be pretty obvious, but transparency is key for us. And actually, we want to make sure that we provide you with visibility into our release scope, the schedule, and the lifecycle. Our release notes include more than just changelog. We actually publish information about upcoming versions, the lifecycle of the version, versions that we are deprecating, and even more than that, I think I saw someone taking a picture before of the release cadence in different regions. We actually publish it. That's part of the release notes. So if you go into the release notes, you can see exactly the 4 days rollout schedule and in which region we are releasing version first, and kind of get more information that you can use to plan your Kubernetes clusters.
Yeah, and as Kobi said, like picking a location is important. The day one zones happen first, and typically the big outages, if they happen, which hopefully they don't, we catch them in day one and day two zones and regions. Additionally, like I was alluding to, and maybe you figured out, like it's important to think a little bit about which version you're picking. I mean, if you want the latest and greatest Kubernetes features or Google Cloud features that come with the new version of Kubernetes on GKE, choose the latest version. But we are very careful about only setting the default when we think it's the right time, when we think this is the version that the majority of the fleet should be on.
While you're thinking about the version, another configuration to think about is node auto upgrade. As I alluded to earlier, either you can manage your node upgrades yourself, or you can have us manage them. With node auto upgrade enabled, anytime that we do a master upgrade, shortly after, we will upgrade all of your nodes as well. We highly recommend you enable this. If you don't, it's your responsibility to stay within the 2 minor version SKU policy that we have. The node auto upgrade feature is actually default now in the Cloud Console, which is the example you'll see on the right. And it will soon be the default in G-Cloud as well. In addition, so we take various automated actions on our clusters. And we recognize that some of those actions, like node upgrades, might cause disruptions to your workload or carry some risk associated with them. So if there are times of day that might make more sense for you to perform upgrades, you can configure maintenance windows to stop automated actions on your cluster for those windows. And there's an example for how to configure a maintenance window up here and more documentation. And now over to Kobi to talk about customers.
So with that in mind, I invite Daniel to share more about their experience as GKE customer and tell us more about their product and their business needs.
Thank you, Kobi. My name is Daniel. I'm the head of engineering at Verda. And so I wanted to share with you how we use GKE or why we chose it as our runtime platform. But first, let me give you a little bit context about Verda. Verda is a company that provides essentially continuous remote care for diabetes. And so we use technology to be able to provide that 24/7 care to our patients. We have clinically proven results. And through technology, we can scale that treatment to lots of patients. Providing care through technology is a challenging area. We need to maintain a doctor-patient relationship through technology asynchronously. Many of our customers are very risk-averse. We're dealing with healthcare. People's lives and health are at stake, and so downtime or a bug could have serious adverse effects. And we're working in a very heavily regulated industry with regulations such as HIPAA. And so part of why we choose GKE as our runtime environment is because it makes some of our concerns easier. GCP is a high-trust certified platform. That's an important certification in healthcare. And a lot of those controls we're able to inherit, and we have a shared responsibility model where we're able to meet the necessary regulation, in part thanks to the help that Google provides. Security updates, super important for us, and the fact that Google can do that for us takes a lot of that burden away so that our engineering team doesn't have to worry about it. And making running a GKE cluster easier essentially removes a lot of operational cost, so our engineers can focus on business needs as opposed to maintaining the infrastructure. That said, there's also challenges we've experienced, particularly around managing all the different GKE versions. So for example, sometimes we want to have the cutting-edge version in certain clusters, so our developers are experimenting with that latest version, but a more stable version in production. Sometimes we're ready to roll out a certain GKE version to production, and so we have a pre-production cluster, and we have to manage that upgrade of versions all the way to production. And we want to be fairly careful also with the windows in which we do this. So we mentioned earlier there's a maintenance window feature, but today that allows you to specify 4-hour windows in which you want to avoid the updates. We love a little bit more flexibility with that. For example, avoiding it during weekends, or sometimes we just sign a customer and we're going to have a big spike of patients, and so we'd like to avoid upgrades during that window. And so back to Kobi, who's going to talk about how those challenges relate to different customer personas.
Thank you. So we just heard from Verda, and thanks for sharing your experience with us. Evidently, one size doesn't necessarily fit all, even though we're talking about managed cloud service. Different customers have different needs, and I want to share with you some other examples. Oh, sorry. So we heard about Verda. We actually created some customer persona to represent different needs from different type of customers. So in this case, customer A, they have a specific multi-weeks certification process for every release, and they have to go through that process and certify that release before they roll it out into production. They're using GKE today, and they are looking to align their internal certification process with the GKE releases. Another example would be this customer. They upgrade today manually. So even though we have the auto upgrade option, they decided to upgrade manually because they want better control and they want to make sure that they understand what they get in every release. They are definitely excited about the ability to test early version of Kubernetes and get better time to market with new capabilities. And in this case, this type of customer, customer C, they are pretty self-sufficient. They know Kubernetes pretty well. They feel very comfortable with it. They want to adopt new feature quickly and maybe even be on the bleeding edge version of Kubernetes. But they also want the ability to manage different environments and maybe have different type of versions in each one of these environments. So with this example in mind, we are excited to share with you some of our upcoming capabilities that will, one, provide you more control and flexibility, and two, will allow us to cater to different type of customers.
An exciting feature we have coming up in Q2 is release channels. Release channels will allow you to subscribe your cluster to releases that match your release cadence and risk profile, keeping the masters and nodes together at the channel that's just right for you. Our goal is that every change is qualified in an earlier channel before it moves to a later channel. So for example, any change that made it to this regular channel would have been qualified previously in the rapid channel. Soon we'll release the rapid channel, where you can expect the latest and greatest releases. Later this year, we will follow with the regular channel, bundling qualified pieces from the rapid channel, with the stable channel soon after. We expect that most of you will want the rapid or regular channels, but if you need our most stable but least featureful releases, the stable channel is for you. There's a simple example here. Soon you'll be able to create a release channel cluster with as straightforward a command line as just saying release channel rapid, and we'll follow with Cloud Console changes later too. And you'll get a cluster whose master nodes are maintained at the newest release that we've qualified internally for GKE. This will be available later this quarter, hopefully.
Cool. So this is something I'm very passionate about. One of the things that I've been working on is the release. And as part of release channels, we want sort of more granular releases, at least internally. And we've been making a lot of new tooling and infrastructure. And some of that's provided in this new open source repository we created called the Cluster Bundle. So if you're curious kind of like how we think about releasing components, like definitely check it out. I mean, what is that going to mean for customers? You won't see it directly, but you'll see it in the form of more stable releases, improved time to market, and better release notes.
So in addition to release channels we just discussed, release channels allow you to inform us with your risk appetite and kind of the type of version or release you want to subscribe your cluster to. We also want to support you in managing your risk or your risk mitigation plans, and Canary Cluster can help with that. So Canary Cluster will allow you to designate a cluster for Canary or staging test and link it or map it with your production cluster or clusters. In turn, what we will do is GKE will sequence new version rollout to Canary clusters first, and we'll give you some time to run your automate test, make sure that everything works, nothing breaks with the new version. And once you greenlight that version, we will roll out the new version to production. The other thing we are going to do as an alpha feature coming up from product is enhanced maintenance windows, which we just spoke about. So right now with maintenance windows, you can specify 4 hours in a day in which that we will respect, and we'll trigger maintenance events only in these 4 hours. But we do hear from other customers that there are other use cases that they want us to support. For example, if you prefer to avoid upgrade during weekends because you are a gaming company and most of the traffic you get in is actually during the weekend, you will be able to use enhanced maintenance windows and set the specific days that you want us to avoid those upgrades or those maintenance events. Other use case might be you are a retailer and you want to make sure that we don't disrupt you with any type of maintenance events during Black Friday, Cyber Monday. So you'll be able to specify a range of dates that we will respect, and we will avoid maintenance windows happening in these dates. And then the last use case is, let's say you know about upcoming upgrade, but for some internal reasons, you need more time to get ready for that specific upgrade. We will allow you to postpone or snooze the upgrade for a specific amount of time to kind of give you more flexibility in getting ready for consuming the upgrade. So just to bring all of this together, because we definitely spoke about a lot of things in this session, our goal is to keep your cluster up and running, up to date, while delivering a non-disruptive experience for your customers and for your clusters. We aim to provide a hassle-free managed service. That's on one side. And the other side is we're trying to balance that with give you more controls for flexibility. If you are interested in any one of the features that I just mentioned that we spoke about today, please follow that link over there and let us know that you want to join one of the alpha programs that I mentioned. Your feedback is highly appreciated, as with any other session. So after this session and after we're done with the Q&A, please take a moment to go through the app and share your experience with this session.